let's continue looking at conditional probability. And with looking at conditional probability, we're also going to look at Venn diagrams. Now, be careful with Venn diagrams because when you're looking at Venn diagrams, you also have to pay attention to the center of the Venn diagrams. What is overlapping? So in a school, 50 students are taking math. So 50 are taking math. 60 students are taking biology. And 30 students are taking both. Now, whenever I talk about a Venn diagram and I draw my circles, and no, I do not draw good circles, and let's say that this is math and this is biology, I don't just put 50, 30, and 60. Okay? I have to start with my innermost part. The innermost part is the overlap, and that's going to be the 30. That's how many are taking both. The 50 that are taking math includes this 30. So actually, the people taking math is going to be 50 minus 30. So there's actually only 20 people taking math only. Because this circle right here is everybody taking math, this total has to be a total for every math that 50. Same with the biology. This circle has to be a total of 60. Because this does not say 60 students are taking only biology. This says 60 students are taking biology. So that includes the 30. So this is going to be 60 minus 30. So there are 30 students taking biology only. Suppose the school has 150 students. So we have 150 students. We have 20 students taking math only, 30 students taking both, and 30 students taking biology only. So that's 30, 60, 80 students taking one of these classes. So we do 150 minus 80. So that is 70 students taking classes that are not biology or math. Okay? And it's important to think about this because we have to pay attention to the fact that this does not say 50 students are taking math only. It says 50 students are taking math. So again, that includes this entire circle. If a student chosen at random is known to be taking math, so we know that they're taking math. So we know that it's out of this 50 students. So we're looking at the probability that they're taking biology. So biology, knowing that they are taking math. Okay? So we know that they're taking math. So that means that we can only select from these 50 students right here because we know that they take math. So that means my denominator now is 50 and my numerator are those that are in their overlap, that middle section. So that is going to be 30, which will simplify into 3/5. There's a formula for this. This is called the conditional probability. This is the event B happens given we know event A happens. You look at the probability that event A, that's the given part, the given is on the denominator, and their overlap, their intersection, is on the numerator. And that's how you would read that. So you put their the given portion on the denominator, and you put their intersection on the numerator. So intersection and the given on the denominator. Okay? So let's look at these. A spinner contains numbers 1 through 10. You spin the spinner one time, and you want to calculate the following probabilities. So we have this is our sample space originally. Probability of landing on a 5, given it's an odd number. So we know it's an odd number. So we know it's going to be 1, 2, 3, 4, 5. So we know that it's an odd number. So probability that it's 5 and odd. So there's 1 5, and there are 5 odd numbers. Probability that it's a 5, given the number is larger than 3. Okay, so let's look at how many numbers are larger than 3. Start with 4, so 1, 2, 3, 4, 5, 6, 7. That's our denominator. We're looking for the number 5. There's only one number 5. Okay. Probability of landing on a 5, given it is an even number. So, given it's an even number, so there are 5 even numbers, and there's 1 5, but our new sample space is this. Do we have a 5 in this group? No. So it's actually this. Probability is this, because we know that it's an even number. If we know it's an even number, can we land on a 5? No. So we actually have a probability of 0, which is highly possible. Okay? Now, let's look at this game. Susie and John are playing a card game. A box contains 2 red and 2 black cards. John randomly draws 2 cards without replacement. If the 2 cards are the same color, he wins. Otherwise, Susie wins. Okay, so he draws a card. It's red or it's black. So there's a total of 4 cards, because the box contains 2 red and 2 black. So 2 red and 2 black. And then he draws again. Okay. If he drew a red, now he only has 1 out of 3 chances. If he drew a red, he has 3. No, sorry. He has 2 out of 3 chances of getting a black. If he drew a black, he has 2 out of 3 chances of getting a red, and only 1 out of 3 chances of getting a black. So, to get a red and a red, it's 2/4 and 1/3, which would be 2 out of 12. To get a red and a black, it would be 2/4 and 2/3, which would be not 8, that would be 4 out of 12. To get a black and a red would be 2/4 and 2/3, so that would be 4 out of 12. To get a black and a black, that would be 2/4 and 1/3, so that would be 2/12. Now, if he gets the same color, he's going to win. So John wins 2/12 plus 2/12 of the time. So John's going to win 4/12. Otherwise, Susie wins. Susie's going to win 4/12 plus 4/12. She's going to win 8/12 of the time. So, do they have an equal chance of winning? No, they do not. Susie has the better chance of winning because it is without replacement. Because he is taking one of the colors, and therefore he no longer has the same chance of drawing the exact same color. So you have to be careful with those types of games.